G'day, Jerry here. This Sony VCR remote was destroyed by battery acid. I'll show you how to clean it up and repair the traces. But that won't fix everything. One of the main components is dead and can't be sourced easily. So I'll show you how I used a $5 Raspberry Pi Pico to simulate it and get it up and working. We're dealing with some gunky stuff here, so I thought I'd better put gloves on. Let's take a look at this board just before we start. So there's the model number, RMT-V408A, revision B, 2001, about 25 years old. I'm using vinegar to neutralize the alkalinity of the battery corrosion, and then I'm going to use isopropyl alcohol to wipe that off after it's reacted. Before I do anything and clean this up 100%, I think I should clean these up, put it back together and see if it works. I don't have the TV with me at the moment, so I can't really test to see whether or not it's working, but you can often see the infrared LED with a mobile phone. So let me just check whether that is correct. So here is one for my TV. I'm pretty sure you can see that. Through the phone, can't see it in reality, like with the bare eye. But you can see it flashing red as I hold it down. So what we can do is we can clean this up, all the terminals up, put it back together and see whether or not that LED is flashing. If it is flashing, then we know despite all of this damage, we don't have to repair any traces, and maybe we just scrape off what's there and put a UV coating over it to protect it for the future. Okay, so now to the laborious task of cleaning up all of these. Let me give you a clear look at what they look like. They are terrible. Oh my God. Wow. That one not so bad, but that is shocking. All right, so what I'm going to do is I'm going to scrape away at it with a dental pick just to get the gunk off it, and then we might just apply a bit of sandpaper. I'll give it a scrub down with a toothbrush as well. Okay, we'll move on to the dental pick. You can pick up a set of these dental picks off AliExpress for $5 or something. They're absolutely fantastic. It's a tool I would never do without. Okay, I think let's now switch to sandpaper. I've got some wet and dry P600, I think it is. Yeah, we still need a bit more. I mean, the most important part is the end bit here where the battery actually comes into contact with it. The rest of the spring isn't making an electrical connection. I think that's good enough. So just to recap, we're not going to touch this side just yet because I think there's enough copper there for it to actually work amazingly. So hats off to whoever designed it and said, no, I'll leave as much copper on there as possible. There's a little bit of crud down there. Gonna get rid of that. That will eventually eat away that leg. I mean, given time, it would have traveled all the way up here and cut through these tiny little traces that are attaching it. So let me just put this back together and we'll just see whether it works now, and then we'll decide what to do about this side. Okay, so Houston, we may have a problem here. I was just looking at the membrane here that's on top of it, and you can see here, this is probably, you know, the most commonly used things. What would that be? The OK play, an OK. Yeah, that looks completely worn out. Now, I did try and just wipe very, very gently, like incredibly gently over these contacts just to clean them a little bit, and they started coming away. So this might actually be a problem for us here. All right, well, we should still put it back together and then see what we get. No use whinging about it. I think that's good enough to put some batteries in. I'm not going to snap it all back together. Are we going to see any activity? Okay, so we're back to the PCB, and what I'm thinking is this is going to be a problem here. You know, I don't think that is still connected. It might have been managed to find its way through all of this crap, but it's probably stopping right here, and we don't know where that goes. It's connected to that. What is that? So from here, this must be all the missing copper. Yeah, so, oh dear. I think I need to clean this up. Oops. Okay, so I've done a bit of poking around with the multimeter in continuity mode, and this is how I think all the connections used to work. So the plan is to wire it all up and see if we can't see the lead emitting something, and if that happens then we can try fixing these up as well. At this stage I have no idea what's going to happen if I apply lead solder to these joints, whether or not they're going to take them or not, but that's what's coming up next. So I've got a chisel tip here, which isn't my favourite to use, but I know it's the best tip for transferring heat. Oh, okay. Oh God, it stinks. Oh, not nice at all. Whew. Hang on, I better get my exhaust fan going. Okay, so that seems to have worked. Let's try this resonator. It's not too bad. I just want to apply some new solder to it. Whoops. What happened there? Okay, that just came all the way off. I'll just put some flux on there just to see whether that helps. I mean, there's no pad left now, so I'm just trying to tin the lead, I think. Okay, so this is the capacitor. Problem is I don't want to damage the traces that are already there. Might as well see if we can join this one here, and then I'll go back and test continuity again. Will it stick to this? Alright, let's find the multimeter and have a look. Check to see whether or not I've done more damage than good. Okay, so now we've got positive going across to that pin. I sure hope that's right. Or we're going to blow the whole thing up and then it'll just be the end of it. Better break out the wire and see what we can do. I created this device ages ago. It's a little device for allowing you to solder some of this enameled wire to a point and then pull it across to another point and hopefully resolder it. I've never really used it in anger, so this might be a good test. I don't like using enameled wire. I can't get that to stick. I do have this very thin gauged insulated wire. It's incredible. It's so thin that you can just pull off the insulation with your fingernails. Absolutely love it. And so that could totally work here in this situation. It's probably my preferred way of doing it, but we'll try and use the little enamel wire spooler. I mean, I made it for that purpose. So this enameled wire, I think I recycled from an old DC motor. Okay, so I need to burn off the end insulation off this and then tin it. The thing I'm most worried about is getting a piece attached to this pin. So I might do that first. If I can't get it to work, I might go for the insulation. Well, it worked. It's pretty dodgy though. Maybe I should have gone the other side. But this wire wrap thing actually, as a holder, it's great. I wonder if I could wrap it around it. Okay, I've managed to create myself a little knot there, which isn't good. And I now drag this across here. Yeah, I can. That works pretty well. Okay, so I've done that. I've got the length right. If I cut this off, got to get it hot enough to burn that enamel off. I should have stripped it back more, but I didn't think that I could wrap it around. Okay, well, that's not bad for the first bit. So the other thing that we want to do is join that also to the negative side over here. I must say I'm really regretting having a second cup of coffee this morning. I'm actually wondering whether I should put a dab of super glue there. Get it in the right position. Super glue will melt with temperature, so I can always remove it. Just let that dry for a second. That super glue is holding, but it's not completely dry. But let's just move on and see if we can't get this to solder down. So if I just hold this on top of the enamel, it should burn off. Send it to me, but no electrical connection. So I've managed to put solder on it without really making a connection. Let me just scrape this along it. Okay, that seemed to work a bit better. Actually physically scraping it off. Okay, just a quick check. So middle pin of the resonator, yes, it's not touching anything else. And the negative pin of the capacitor, correct. So we've got our power going to this pin 20. God, I hope that's right. So we just need to connect to these two. So this one to pin 3 and this one to pin 2. No problem. So we're going to have to cross over the wires, but hopefully that won't matter. So what did I say? It was pin 3. Was this one here? So we want to make a right angle turn out there. Look at that. Not bad at all. device is working pretty well. So why don't I just cut it off? See if we can't scrape the end. I should have been using the other tweezers. Let's see if we can't get a little bit of solder on the pads. Might also help if I had thinner solder. Seems to be stuck. Whew. Okay, for now for the other lead. Alright, so this is what I've done so far. I have made all of these connections up, and I'm just going to test them with my multimeter, continuity mode. So this is the negative battery terminal here, and this is going to the middle pin of this oscillator. And it's also going over here. This is the negative lead of the capacitor, smoothing capacitor. And that's going down there, so all of that's okay. And to be sure, I also put a link over here to the ground pin of the chip itself. So I made sure all the grounds were connected. And then we've just got this one here, the other side of the oscillator that goes here. There we go. And then this one over here goes to there. So it looks a bit dodgy, but it is all connected. So what I'm going to do is I'm going to connect up the power, and then we're going to see what happens. We're going to use my bench power supply to inject 3 volts into this. Okay, so we've got 3 volts connected into it. I'm going to put the buttons back on it, just so that we can be able to bridge some of these button contacts. See if anything happens. So at the moment I'm just looking at my power supply and it's not drawing any current at all. And if I push some buttons, it's not drawing any current. Doesn't look like it's activating. So let me just go to voltage and just check the voltages. So from negative to positive, we should be getting 3 volts, 3.1 volts. Okay. So we've got 3 volts across there. Got our 3 volts there. Check some of these pins. 0.5 volts, 0.5 volts, 0.5 volts, 0.5, 1 volt, 1.1. Interesting. I mean, over this side, 2.9, 3 volts, 3 volts, 0.4. Okay, so the chip is getting power. Whether or not those voltages are anywhere near correct, I'm not sure. Yeah, so I'm not sure about this oscillator. If the oscillator isn't working, then probably the chip isn't going to be driven, and so nothing's really going to happen. There are voltages on the chip itself, so that's something anyway. I think I might break out my little oscilloscope and we'll just see if we can see any signals. Okay, so let's have a look. We're set at 1 volt. So I just want to probe this chip. So we're getting 3 volts there, and it doesn't look as though we're getting any signal, just a straight 3 volts coming out. And on this side we're getting 1 volt. No signal. Interesting. And I'll just check the pins. They'd probably be the same. Yes. Why wouldn't they be? Interesting. So if I press some buttons, hold down some buttons on the remote now, and we'll just try that again. No. Okay. So here's the problem. This oscillator here is very difficult to get cheaply. I could get 50 of them for like $20 off AliExpress. It's not an expense I'm going to incur just to see if this works. So where to from here? So what I'm going to do is get a Raspberry Pi Pico that I had lying around, a $5 Pico. I'm going to put a very small program on there that just pushes a clock signal out of this pin, and we'll connect that up in lieu of the oscillator and just see whether or not this chip down here actually works. It only took about 5 lines worth of code to do that. I think it's a good way of confirming whether this chip is dead or alive. Okay, I've got my little Pi connected up to the oscilloscope, and we'll just check out that it's producing a signal. There we go. 3.79 megahertz. Close enough, I think. It is a bit over 3 volts. So technically I should bring it down to 3 volts, but I think that's close enough. You know, 3.6, 3.5. I mean, let's face it, this thing's pretty much kaput anyway. So there we go. We've got a cheap little signal generator there that we can replace the oscillator on just for a quick test to see if this chip is dead. So why don't I solder this in place and let's give it a go. Okay, so I think I might just disconnect these leads here. So let's plug the Pi in, power it on, and let's see if it's providing us with a clock signal. Yes. Got our 3.8 megahertz signal now going into pin 2. So has anything else changed because of that? Let me just check. So we're getting 3 volts, 3 volts, 3 volts. What was that? No, doesn't look as though anything's changed much. Though there does look like to be a bit of a warble on those pins that wasn't there before, now that the clock is there. Okay. So I've just put the button matrix back on there so I can hold down some buttons to see whether anything happens. And the first thing I want to see is whether or not it draws any current. Actually, it's drawing 0.01 of an amp, whereas before it wasn't drawing anything. So it's almost as though that chip is active, maybe. I don't know. Hang on. Let me just turn the power off. Okay, so without me pressing any of the buttons, it's drawing a little bit of current, but I don't think that means much, because until you press the button, that really shouldn't be doing anything. Then when you press the button, that should draw a little bit of current as the remote control wakes up. So what do I need? I need my camera to see whether or not the LED is lighting up. Oh my God, it's freaking working. I don't believe it. Yeah, absolutely. I can see it's firing. Oh my God. I'm going to have to splice this footage in from my phone, but it is definitely working. I'm pressing the button and I'm seeing on my phone the flash of the infrared signal. It's 100% working. Wow. Can you see that? That is the flash of goodness. So yes, it is repaired. It does work. All it needed was an oscillator, and our little Pi as a makeshift oscillator has definitely done the job. Amazing. Well, how good was that? So we did get some life out of this remote control using a bodged together signal generator. Amazing. Yeah, I got to test out my handmade little wire helper gadget. So I've had a lot of fun. I did talk to my friend. He has already sold the VCR that this belonged to, saying that it didn't come with a remote. It's just a pity that it's difficult to get this particular speed of timing component. There's so much damage to this. You couldn't guarantee that it's still not eating away underneath this chip. We'd have to remove the chip and clean it under there to be 100% sure. So I think I might just leave the video here. I'll pack all this up, put it into a bag, and maybe I'll come back and revisit it in the future if I ever see one of those components online for cheap. Or perhaps one day I might get another orphaned Sony remote control that's completely dead, but it has the component in it. Who knows? I hope you enjoyed that video. If you like this sort of content, think about subscribing to my channel, give me a thumbs up, all that sort of stuff, and I'll catch you on the next video. Ciao.